Welcome back students to IMST online class, and today we are going to study about a new concept, refraction. Well, I'm sure you must be wondering what is refraction or what is this phenomenon. Okay, what you see in my hand is a tumbler, glass tumbler, which is filled with water, and here we have a pencil. Let me show you a trick. You see this pencil is straight. What if I tell you it's not straight actually? Pay close attention. It's straight, right? Now, so what do you see? Okay, the pencil, what you see, which is dipped inside the tumbler, you can say it is appeared to be a little bit bigger, right? The image is enlarged and it is appearing bent. It's not straight. So what is it? Is the pencil straight or not? Well, actually the pencil is straight, but our eye is deceiving us by showing that the pencil is not straight, or the pencil bends when it is going inside the water. But does the pencil really bends when it is going inside water? That's a question. But it's not bending. Then what is bending? Why is the pencil appear to bend? What is bending here is the light, and this phenomenon is called refraction. And this is what we are going to study today. So what is refraction? Refraction is a phenomenon. Just like reflection, refraction is also a natural phenomenon occurring in our day-to-day life. So by definition we can say refraction is a phenomenon of bending of light, right? Light ray that is bending. That's why we could see the pencil as if it is bent. So refraction is a phenomenon of bending of light ray when it moves from one medium to another medium. Understood? So there's a word coming, medium. What does this medium mean? Medium means the path in which the light is going through. So medium can be air, water, vacuum, solid, anything. Okay, whenever there's a change in the medium, the light ray bends. Okay, suppose the light ray goes straight, as we studied in the first video of reflection. Light generally travels in a straight line. So suppose light ray is going in a straight line, but suddenly there is a change in the medium. So what will happen? When the medium changes, the light will bend. Okay. Now the question is, why does light ray bend, or why there is a need for the light ray to bend? The reason is it happens because of this change in speed of light. Whenever there is a change in the medium, the speed of the light changes, and due to this change in the speed of light, the light ray bends or appears to bend. Okay, let me give you a small example here in Malkangiri. Suppose you're going from IMST school to Balamira. Okay, on any normal day when the road is empty, you can go with your high speed or a normal speed. But remember, when you're going on a Tuesday afternoon, in Tuesday afternoon we have our weekly market, and since we are going in a weekly market, there is a lot of crowd in that weekly marketplace, so you have to slow down your cycle and then only you can move. So what happens? That whenever there is a change in the area which you are moving, you change your speed. But so what actually changed in this case, or what actually happened so that the light ray bends? The actual change occurred in the density. We all know what does density means, right? How much crowded a thing is, that is, it's called its density. So on a Tuesday, the density of that area increases because on that particular place a lot of people are gathered. So that's why the density of the place has increased, and the gap which is available for you to move has decreased. So you have to reduce your speed. Similarly, when the density of a medium increases, the light ray is also to reduce its speed, because the free path which is available for light to move, it also decreases. That's why this phenomenon of refraction occurs. Okay, so note it down. Refraction occurs due to change in density. Okay, so based on this density, mediums are classified into two types: denser medium and rarer medium. Okay. So what do we have? Based on the density, we have optically denser medium and optically rarer medium. Okay, optically denser medium means high density. And optically rarer medium means low density. Okay. So now you might have understood what does this density terms and how it is related to this path of the light. Okay. So from that we can say that air is less dense. On the basis of density, we can say that air is less dense than liquid, which is less dense than solid. So solid has the highest density, and the least density is seen in vacuum. In vacuum, you can see the least density. So the light travels the fastest in vacuum. Okay, and the least in solid. Understood? Noted. So we understood that bending of light is refraction. But how to know that in which direction the light will bend? Okay, so let's see how it bends and in which direction. So we studied that on the basis of density, a medium can either be a denser medium or can be a rarer medium. So let's see the two cases. First, when light travels from rarer medium to denser medium. Okay. So first we will see that what happens when light travels from a rarer medium to denser medium. It is just the same case what you saw in that dipping the pencil in the tumbler. Okay. So let us consider this is the point of intersection of both the medium. Okay. Here is a denser medium. We can consider water, and here is a rarer medium like air. Okay. We can consider air. Or here we can consider as water. Okay. So suppose this is the incident ray. Okay. The incident ray is about to enter from a rarer medium to a denser medium. So this is the point of incidence. So we will draw a normal here. We all know what's a normal, right? Normal is a perpendicular. Okay. It's a perpendicular. This is the normal. Now, this should be the path of the light. Okay, it should go in this way, in a straight line. But since there is a change in the medium, the light ray will bend. And how it bends? Since it's traveling from a rarer to denser, it will bend towards the normal. Okay, towards the normal. It will go like this. Okay. So this is the incident ray. So after refraction, this ray we are getting. This is a refracted ray. Okay. So how it bends? Okay. That is when light travels from rarer to denser medium. It bends towards normal. Okay. Now the second case, that is when the light is doing just the opposite. When the light travels from denser medium to rarer medium. When light is traveling from denser medium to rarer medium, okay? Suppose this is the point of intersection of two media, okay? So here is the denser medium, what you can concluded, okay? And here is the rarer medium. So in this case, let us consider light is coming in this way. So this is the point of incidence. This is the point of incidence. This is the incident ray. So here we draw a normal. Now the light ray should go along a straight line, right? It should have gone like this. In a straight line, it should have moved. But since it is moving from a denser medium to a rarer medium, refraction will take place, and the light ray, what will happen? It will do the opposite. It will move away from the normal. This is the normal. So instead of going like this, it will move away from the normal. This way. Okay? This is the incident ray, and this is the refracted ray. Okay? So what happens here? It bends away from normal. It bends away from the normal. So you can say, what is this angle? The angle between incident ray and normal, it is called angle of incidence, and the angle between normal and the refracted ray, it's called angle of refraction. Okay, not reflection, refraction. Okay, so in this case, when the light is traveling from a rarer medium to denser medium, the angle of incidence is greater than angle of refraction. Okay, and when the light ray is traveling from a denser medium to rarer medium, here you can see this is angle of incidence, and this is angle of refraction. So in this case, angle of incidence is less than angle of refraction. So with this also we can say that we can decide what is the base of the medium, what is the type of the medium. If angle of incidence is greater than angle of refraction, then it is that is the light ray is traveling from a rarer medium to a denser medium. If the angle of incidence is less than the angle of refraction, then the light is traveling from a denser medium to rarer medium. Understood? Pause the video and note it down. So you understood what is refraction, right? So since refraction is a natural phenomenon, so we have to obey some laws in order to study more about refraction. Just like reflection, refraction also has two laws, and it is quite similar to that in case of reflection. Let's see. The first law. The first law of refraction states that the incident ray, the refracted ray, the incident ray, the refracted ray, and the normal. The incident ray, the refracted ray, and the normal at the point of intersection of two media. Okay, from two media all lie in a same plane. Okay, so this is the first law of reflection. The incident ray, the refracted ray, and the normal at the point of intersection of two media all lie in a same plane. Okay, or when it all lie on a same plane. Now this is the first law. Then second law. Second law, what it says is that the ratio the ratio of sine of angle of incidence, the ratio of sine of angle of incidence to the sine of angle of refraction is always constant. Okay, so pay attention, this is one of the most important law for laws of refraction. Okay, the ratio of sine of angle of incidence to the sine of angle of refraction is always constant. So mathematically you can say sine I by sine R is always constant. Sine I by sine R is always, sine I by sine R is always constant. Okay, this law is also called as Snell's law. Okay, it's named after the scientist Snell. This law is also called as Snell's law. Which one? The second one. The second law of refraction is also called as Snell's law. Okay, pause the video and note it down. So we studied about the two laws of reflection, and the second law is called as the Snell's law. Let's try to understand it better. What is Snell's law? Actually, Snell is the name is given upon the name of the scientist, whose name is Wilbrod Snellius. Okay, the scientist's full name is Wilbrod Snellius. He gave this law, Snell's law. And what does that law exactly says is that in refraction, sine I by sine R is a constant. Okay, where sine is a function of a mathematical function of trigonometry, which you are going to study in mathematics in later classes. Okay, it's a mathematical function involved in trigonometry. And sine I by sine R, which is constant, that constant is called as refractive index. Okay, refractive index of the medium. Okay, this constant is known as the refractive index of the medium, which is denoted by a Greek alphabet mu. Okay, so sine I by sine R is equal to refractive index of the medium. Now, what is refractive index? Right, that's the question arising in your mind. Refractive index. Well, actually, it is a comparative term. Refractive index is a comparative term. What's a comparative term? Means it's not something which is exactly same for all these things. It's a comparative term. Okay, compared to another medium. Refractive index of one medium is related to refractive index of another medium. Okay, it generally depends on one medium to another. It varies from one medium to another. Okay, let's see. You will understand it. By definition, what you can say, refractive index, it is a measure. It is a measure for the reduction of velocity of light in a medium. Okay, so what does that mean? It is a measure for the reduction of velocity of light in a medium. So what is that? Already we studied that refraction occurs due to change in velocity of a medium from one medium to another when the light ray is going. since the velocity of the light ray changes, it bends, a refraction occurs. So how much velocity will be reduced? That value is given by the refractive index. Suppose the refractive index for glass, okay, is equal to 1.5. Suppose the refractive index of glass is 1.5. That means the velocity of light in glass is 1.5 times slower as compared to in vacuum. Okay, so that is the refractive index determines. It helps to determine how much the velocity is going to reduce in a particular medium. Okay, this is the general definition for refractive index. There are other definitions also, other forms by which we can calculate the refractive index of a medium. Like, as I have already said, refractive index is a comparative term. So, we can say that refractive medium or the refractive index of first medium with respect to the second one. The refractive index of first medium with respect to second medium. Two mediums are needed for refraction is equal to velocity of light. Velocity of light in medium 2 in the second medium divided by velocity of light in medium 1. Okay, that is refractive index of first medium with respect to second one. We are calculating the refractive index of first medium with respect to second. That is velocity of light in medium 2 divided by velocity of light in medium 1. So, refractive index of second medium with respect to first one, what it will be? It will just be the reverse. It will be velocity of light in first medium divided by velocity of light in second medium. Okay, understood? Note it down. Okay, so we are studying about the mathematical form of refractive index. Now, we studied what would be the refractive index when light is traveling from one medium to another. Now, if one of the medium from which light is traveling is air, okay, if one of the medium is air, in this case the refractive index of the other medium, the refractive index of the second medium is equal to speed of light in air divided by speed of light in that medium. Okay, speed of light in air divided by speed of light in that medium. Okay, so symbolically we can write this as mu is equal to speed of light in air is 3 into 10 to the power 8 meter per second, which is symbolically represented as c divided by b. Okay, so refractive index can also be defined as the ratio of the velocity of light in air to the velocity of light in that medium. Okay, mathematically refractive index, or this is also called as absolute refractive index. Absolute refractive index. Understood? So this is absolute refractive index. Mathematically we can say absolute refractive index or refractive index is the ratio of the speed of light in air to the speed of light in that particular medium. Understood? So this is how you can calculate the refractive index of a medium, or you can calculate the velocity of light in a particular medium if you know the refractive index. In your book, your table is given. Okay, in that table, refractive index of various substances are mentioned. Okay, have a look at that. Now, okay, so far we studied about refraction, how it happens. Now let us look towards another object. Okay, refraction in glass slab. So now we are going to study how refraction occurs in a glass slab. Okay, you see, what's there in my hand is a rectangular glass slab, and it is made up of glass, right? This has some kind of thickness, so the light ray will move from air into the glass, then again to air. So in this case, there will be refraction in two places, in this surface and also in this surface. So just see how is the image of this pencil. You can observe. Okay, what do you see? In this case, you can see that the part of the pencil which is looking inside the glass slab is completely displaced, isn't it? This displacement is called as lateral displacement. Check it, take a look again. Okay, this displacement is called as lateral displacement. So let's see how it happens, lateral displacement. So let us consider this is a rectangular glass slab. Okay, so this is the incident ray that is incident on this surface. So if we consider, this is the normal. So this should be the actual path. The light ray should have followed, but now this is the air medium. Now light is moving from air to glass. So which side the ray would bend? It would bend towards the normal. That is, it will go like this, isn't it? Instead of going in this direction, it will bend towards the normal, and it will move up to this surface. Now in this case, again the light ray is changing the medium. It is again going from glass to air. In this case, this should be the path taken by the light ray, but instead of that, it will move away from the normal. So it will move in this way. Okay, understood? So what you can see here, this ray and this ray, this is called as incident ray. Incident ray. This is the refracted ray for this incident ray, and this is incident ray for this one, right? And this one is the emergent ray. Emergent ray. Okay, the incident ray and the emergent ray are parallel to each other. They don't lie in the same line, but they are parallel to each other. So if we remove this one, okay, this rectangular glass slab, so there's a displacement taken by the light ray, right? This displacement is called lateral displacement or lateral shift. Lateral displacement or lateral shift. Now here, this is the angle of incidence, this is the angle of refraction, this is the angle of refraction, this is the angle of incidence for this surface, and this here is called as angle of emergence. Okay, represented as small e. Angle of emergence. So this is how refraction occurs in a glass slab. Understood? So here in this case, you can see at two places refraction is occurring. Here, when the light is moving from a rarer medium to a denser medium, and here in this surface, when the light is moving from a denser medium to a rarer medium. Understood? Good. So what we saw was how refraction occurs in a glass slab. Next, we are going to see how refraction occurs in prism. Okay. Now this is a prism, a three-dimensional wedge-type refracting surface which is made up of two triangular surfaces at the bottom and 3 rectangular surface at the sides. Okay, this is a prism. And how refraction occurs in this case. Okay, now generally the refracting surface is taken to be triangular in a prism. Suppose this is the triangular surface of the prism. This is the incident ray. So if we draw a normal here, this is the normal. So the light is moving from a rarer medium air to a denser medium glass. So instead of going in this path, what will happen? The light ray will deviate. It will bend towards the normal. It will move like this. That is, it can move parallel to the base. Okay. Then when it intersects this surface, so this is the normal for this surface. So here in this case, the light ray might without the absence of this surface, the light ray would have gone straight. But since in this case again the light will refract, because light is now moving from a denser medium to a rarer medium, it will move away from the normal. So in this path the light is going to refract. Okay, if you extend this one, okay, this is called as D, or the angle of deviation, where D is known as angle of deviation. Okay, now this is the incident ray of the emergent ray. This is angle of incidence, this is angle of emergence, and this is the angle of deviation. Means the light deviates with this much angle for a prism. Okay, so this is how refraction occurs in a prism. Okay, note it down. So now you understood how refraction occurs in a glass slab and in prism. Now scientists, they wanted to make a surface in which they can use this refraction to converge or to diverge the ray of light. Okay, they wanted to converge the ray of light to a particular point, or they want to diverge the ray of light. So what they did, they combined the surfaces. Okay, that is the prism and glass slab, and they made two different structures. Okay, and that structures are called as spherical lens. Let's see how they did. First one, what they did is that they took a glass prism. Suppose this is the side part of it. Sorry, not a glass prism. They took a rectangular glass slab, side part. Okay, and here they added two prisms. Okay. Now, this is one surface what they made, and one thing what they did, other thing is that they took the rectangular glass slab, and in the other case, they took the prism in an inverted way. They kept one prism inverted in this case. Okay. So what they observed in this case was, when parallel beam of light fell on this surface, okay, in both these cases, when parallel beam of light fell, okay, in this case, they observed that after refraction, they all, in this case, they converge to one point. Okay, in the second case, okay, in this case, generally, the light ray after refraction they diverge. Okay, this one is a little thin. Okay, so they named this as the converging lens, and this they called it as the diverging lens. Now, it was not easy to always fix two prism and one glass slab together to obtain such kind of structure. So they made a single structure based on this thing. Okay, in this case, single structure form was like this. Okay, it's like this. Okay, and in this case, the structure form was like this. So this was the structure for diverging lens, and this is the structure for converging lens. This is also called as convex lens, and this is called as concave lens. Okay, don't get confusions. The light at first it will go inside a cave, right? Cave-like structure, it is going inside. So they gave it concave lens, and this is convex lens. Okay, so generally from sideways they appear in this way, but exactly if you see concave and convex lens, they are generally circular. Okay, for example, let us consider these two lenses. Okay, you can see here they are circular. So just seeing the lens from a distance, you can't say which is concave and which is convex. But if you touch it, you will see in one case at the edge, okay, at the center, it is getting narrower. So it's a concave lens. This lens is a concave lens. It is thicker at the side and it is narrowing at the center. And this is convex lens. Okay, it is narrow at the edge and thicker at the center. Now convex lens are converging lens, and they are also used to magnify an image. You can see there are some stones here. If you put a convex lens in place of it in front of it, you can see the image of the stone is increased or enlarged. Okay, and the concave lens, in this case you can see the image is diminished. Okay, so how it happens, how this diminished image is formed, that we'll study in the next video. Until now, study what you have learned properly and do your homework. Okay, so this is for now. Thank you. Have a nice day.